Hello, everyone, and welcome to my talk on how to deploy intrusion detection honeypots. Who am I? My name is Anicet Fopa Tchoffo, and in my day-to-day, I work as a security consultant at the University of Leeds, looking at security from both sides of defense, offensive and defensive. I'm also heavily involved in security architecture and DevSecOps. Today, I'm going to talk a little bit about cyber deception, more specifically, how we can use honeypot as part of that strategy. And the goal here would be to complement our existing security controls in order to detect intruder in our network more quickly. According to the latest IBM Cost of a Data Breach report, which studied over 600 organizations that suffered a breach between March 2023 and February 2024, it took on average over 180 days to detect a breach and over 60 days to contain it. So if we have detection technologies like firewalls, IDSs, EDRs, and SIEMs, why is it taking us so long to detect intruders on our network? One of the reasons is that these technologies are designed to look for evil. Whether that's signature-based or behavior-based, they're searching for actions that appear malicious. And the problem with that is attacker has become very good at making their activity look normal, making it incredibly difficult to differentiate them from legitimate users. So we need a way to change the game. What if we create resources on our network that have no production value, meaning legitimate users should never interact with them under normal circumstances? For these resources, normal would be defined as no interaction. Like if no one's touching it, everything is fine. But if someone does touch it, that interaction alone is decisively abnormal and immediately actionable. And that that principle is one of the fundamental components of cyber deception. So what is cyber deception? Cyber deception is a strategy where we intentionally create and deploy fake resources that mimic valuable part of our digital environment. And the idea here is to manipulate what an attacker sees, thinks, and does. And the key idea is this. If the fake resources that would replace on our network look and feel exactly like the real resources, an intruder will have no real way of differentiating between what's real and what's fake. And all the attacker needs to do is interact with a single fake resource to be detected. So with that in mind, it means we can now use cyber deception to complement our existing security controls to speed up the time that it takes us to identify an intruder on our network. Cyber deception itself is a strategy and not a technology. However, one of the primary technology used to implement it is honeypots. So honeypots are the actual technological resources that we place on our network that no one should ever touch. And if someone does touch one, we know something's wrong straight away. Broadly speaking, honeypots can be categorized into three main types. We have honey systems, honey services, and honey tokens. Honey systems are entire operating systems used as a honeypot. Think of providing an attacker with a full-blown Windows 10 device, a Red Hat Enterprise 9, and so on. Using a full-blown operating system as a honeypot is something that's really difficult to do properly because that operating system might have vulnerabilities that you're not aware of, and an attacker might do unexpected things and take advantage of a vulnerability that you're not aware of and break contain. So for that reason, we're not going to be focusing on honey systems in this talk. Next on the list is honey services. Instead of full operating systems, these mimic specific applications, services, or network protocols. Think of things like fake web servers, fake RDP server, VNC, MySQL, and things like that. And finally, we have honey tokens. These aren't systems or services in the traditional sense. Instead, these are pieces of fake data or bogus artifact, things like fake documents, fake credentials, fake database tables, fake DNS records, and so on. And when it comes to deployment, these different types of honeypots are not mutually exclusive. They're usually powerful when combined. For example, you can have a system configured with multiple honey services that also has honey tokens scattered around its file system. It's all about creating believable and enticing lures for the attacker. Okay, so we know what honeypots are, we know their potential, but how do we actually use them in real life? Broadly speaking, honeypot deployment fall into three main categories: research honeypots, resource exhaustion, or attack detection honeypots. For the sake of brevity, we'll be skipping over resource exhaustion honeypots today and focusing more on research and attack detection honeypots. So let's start with research honeypots. These are the ones that you typically deploy outside your network boundary, or maybe in the cloud, to capture proliferation of worms, network scanning, what generic bad guys do, or general threat intelligence collection. There's some value in deploying honeypots this way, but depending on your maturity level, this information may or may not be useful to you because it may not be useful to you from an intrusion detection perspective, because when you expose an IP address on the internet, it usually takes less than 2 minutes before people start, scanners and script kiddies start probing it. So the fact that someone is attacking it is not really a surprise, but you can still leverage that for other things. But here we are going to be focusing more on the intrusion detection stuff aspect. So next we have attack detection honeypots. These are going to be the core focus of our discussion today, and these are the ones that we deploy in our network that no one should ever touch, and that no one should ever touch. And if someone does touch one, we know something is wrong. And to deploy these honeypots properly, we need to fully understand ourselves. We need to understand what our critical resources are, what we're trying to protect. But more importantly, we need to understand what an attacker will do, what techniques they will use when they are in our network, so we can properly lay traps that they will trip when moving around. So basically, we're trying to give them what they're looking for, except it will be, highly convincing decoys. So to properly understand what actions an attacker will do when they are inside our network, we can leverage the MITRE ATT&CK framework, which is a knowledge base of various different techniques. Attackers will very different steps attackers will take to compromise our network. It is broken down in tactics, which is what an attacker will try to achieve, and techniques and sub-techniques, which is how an attacker will do it. So honeypots can be used to some extent to detect most tactics in the MITRE ATT&CK framework, but today we're going to touch on a few examples of how to detect things like initial access, credential access, discovery, lateral movement, collection, and even data exfiltration. All right, so now that we've armed ourselves or gained some understanding of what techniques and attackers will use on our network, how can we use honeypots to detect that more quickly? To gain initial access into our environment, attackers will typically either compromise one of our externally exposed resources like our web servers or VPN gateways and things like that. But based on data breach report in the past few years, it's more likely that they will gain access by through a user workstation, maybe one compromised through phishing. And once they have access to a system in our environment, especially in a Windows environment where everything is tied to a credential, one of the things that they will do is try to get more credentials. And one common way attackers will try to get more credentials is by dumping them from the memory of a system that they already have access to. And with Honeypot, we can detect that by planting fake credentials in the memory of our systems and watch if anybody tries to use them. Another common way of an attacker will gain credentials in our environment is by listening to multicast name resolution protocol broadcasts like the one used by LLMINAR, NetBIOS, multicast DNS, and things like that, hoping to obtain credentials by poisoning the responses. And we can detect this with honeypots. We can set up honeypots that will advertise fake credentials using these protocols and watch if someone tries to use them. It is very rare for an attacker to land into an environment and know exactly where everything is, where your crown jewels are, where your vulnerable systems are, and things like that. So typically, to get the lay of the land, they will have to enumerate, they will have to search and find what systems are out there. And one way they do that is by scanning the network. They'll typically set up a subnet on a scanner or a tool, and it will go out and find all systems out there. And we can detect this with honeypots by, setting up service honeypots around our network that they will trigger. That will trigger whenever their ports are probed. Looks like there you go. Another thing to remember is that attackers are never exactly where they need to be when they first compromise our environment. Typically, they need to search, they need to move around to achieve whatever their goal happens to be. If it's malware, they need to move around to deploy the malware or ransomware. If they're trying to steal your data, they need to move around to get to it. And one thing we can do with honeypots is set up honeypots around our network that they will trip when they are moving around our network and will be alerted. Once an attacker has made it inside your network and moved around a bit, they will start looking for the type of the data that they're actually interested in. This could be things like your intellectual property, your financial data, your personal information, anything of value. And with honeypots, we can detect this kind of behavior by creating fake database tables or fake documents inserted within real data with interesting names or something that will, draw the attacker's attention and be alerted when someone accesses it or tries to use them. Quite often, our network includes non-traditional IT systems, things like IP-enabled boilers, industrial control systems, building management systems, all these types of embedded computing devices. And these are gigantic avenues for attackers. They are huge targets, but the problem with them is they are typically black boxes from the traditional monitoring perspective. You cannot just install your EDR or SIEM agent on the smart thermostat controlling your building's HVAC system. And here, honeypots offer a great opportunity to gain at least some level of visibility, because we can deploy honeypots next to those resources, mimicking the application and services that they use. And if someone starts, interacting with these embedded devices, chances are, if a honeypot is next to them, they will also interact with our honeypot, which, at least from an intrusion detection perspective, will give us an indication that someone is poking around. Right. So we designed the honeypots, we deploy them, but that's only, half the job done. We need to couple them with appropriate logging and alerting. I like to equate that to, deploying a very high definition CCTV system. But if you don't actually watch the footage, or even worse, if you don't connect it to a recording device, that's not going to be very useful to you. So we should log the activity that happens to our honeypot, and we should couple that with, we should make sure that all the logs are forwarded to a centralized location, and we should configure proper alerting and incident response procedures so that whenever someone interacts with our honeypot, we are alerted and we are able to investigate and respond accordingly. Now, the more believable our honeypot is, the more intelligence we might be able to gather from the attacker. Let's take a service honeypot, for example. If an attacker just tries to connect to it, we know they're there. Even at this point, even if they realize it's a honeypot and stop interacting with it, at least we know they're there. But if we make it believable enough and give them an option to authenticate, they might authenticate using credentials that they already have access to in our environment, and this might give us an indication of whose credentials they have. Once they've authenticated, if we give them access to a file system, they might start running keyword searches, looking for a specific type of data, or they might, be looking for specific directories, and this might give us an indication of what they're looking for. And oftentimes they will start, uploading or downloading their tool set, which would give us an indication of what they might try next. Here's a real life sample where we collect things like connection, authentication, commands, and downloads with honeypot. The top one is from a honeypot called ADB Honey, which is a honeypot that emulates an Android device. And we can see where the attacker is coming from in our network, and some of the actions, taken on the system. We can see they've connected, authenticate, type some command, download some scripts from the internet, and then continue typing some more commands. Below we have authentication logs from a honeypot called Diona, which here are emulating a Microsoft SQL Server, and we can see the attacker trying to authenticate with credentials, domain credentials that they already have access to. Now, this next topic is super, super important, because you do not want your honeypot to help the attacker's agenda. Therefore, we must adequately harden our honeypots so that an attacker does not do anything beyond what we allow them to do. And here are a few resources that you can look into when it comes to hardening. The Center for Internet Security, CIS, publishes benchmarks that will help you harden your operating systems and application. They're always a fantastic starting point when working on your hardening configuration. Honey services are typically script, and it's generally recommended to deploy them in container within the system where you want to deploy them, rather than on the system itself, because containers give you additional isolation option that you may not have when deploying it directly onto the system. CIS benchmarks are typically distributed in PDF format, which can be a bit time consuming when it comes to copy and pasting and building your configuration files. But luckily there are other publicly available resources that you can leverage when it comes to hardening your systems. For a Linux host, you can, for example, leverage the Compliance as Code project, which provides you with bash scripts, Ansible playbooks that you can use to harden your system compliance to the CIS benchmarks. And for Windows hosts, you can leverage ready-to-use group policy objects provided by the Microsoft Security Compliance Toolkit or the Disaster. There are a lot of products out there that will make it very easy for you to deploy honeypots. Some are commercial, but some are free or open source. Now, here are a few open source options that you can look into. They all provide you with a framework that makes it easy for you to deploy things like service honeypots. We talked a little bit about the importance of centralized logging and monitoring. On this list, Open Canary and Teapot give you an option to deploy an infrastructure that will automatically monitor your honeypot. So if you don't already have one, those are very good options to check. If you want more tools, I would recommend you checking the Awesome Honeypot project, which is a community maintained list of dozens and dozens of open source honeypots. So, I recommend checking it out. Now, when it comes to deploying service honeypots, for example, here are a few things that you may need to think about when doing them. Remember, we are telling a story to an attacker, and we want that story to be as believable as possible. So when it comes to service honeypot deployment, these are a few things that you can think about. Things like your port configuration. We talked in the previous slide a little bit about some framework that will allow you to deploy multiple service honeypots on a system. And in some cases, they will allow you to have one that, listens to, all 65,000 ports on the system. Now, if you're doing something like resource exhaustion and things like that, that might be useful. But if you're purely deploying a honeypot for intrusion detection, and you're trying to make it look like a production resource, in production, it's never the case where you have systems, not never, but it's rarely the case where you have systems that listens to all 65,000 ports. So when it comes to port configuration, usually less ports are often more believable. When configuring your honeypot, you'll have to decide whether to make it similar to production or different from production. And there are pros and cons to doing it one way or another. Okay. When making it similar to production, it's less likely to raise suspicion, but there are little tweaks that you can make to draw the attacker's attention to it. Things like making it slightly more vulnerable. Let's say you're deploying it next to a web server that has a web port, RDP, and maybe SMB. For your honeypot, you can make it web port, RDP, SMB, and maybe add something like VNC if your production resource only supports SMBV3, maybe make your honeypot support SMBV1 or up to, something that will draw their attention. You can also give it interesting names that suggest, the resource is less secure. Let's say you have a naming convention that identifies your production resource as prod. You can deploy your honeypot and call it dev or test or stage, something that will suggest it's less secure than the production resource. Obviously, don't call it honeypot. If you want to make it very different from production, that's more likely to raise suspicion. But some attackers usually look for one-off targets or outliers. So depending on who you're dealing with, they may or may not take the bait. When it comes to honey tokens, again, I will invite you to check the awesome honeypot list that has, a bigger list of honey tokens out there. But I thought I'll mention a few here. You can use invoke runners to place credentials in memory. You can use responder guard, and then you have one of the NVPs, which is canary tokens, which allow you to deploy, all sorts of honey tokens around in your environment. Now, honey accounts are one of the easiest honey tokens to deploy in your environment. And here are a few things to think about when deploying honey tokens. Obviously, make sure it doesn't work the credentials don't work in your production environment. And you can monitor things like failed logon or account lockout. You can allow it maybe to work in your honeypot environment, but please don't make it work in production. In an AD environment, when setting up a honey token, a honey account, please make sure the logon count is not 0, because 0 means that account has never been used. Depending on what you're trying to get the attacker to think that account is used for, advanced experienced attacker will check this value to see if that account has been used before or things like that. So you can use something like a script to log onto your environment multiple times and increase that number. And when deploying these, you also have to put them in locations where you are sure if someone's poking around where they're not supposed to, they'll find it. Things like put it in a config file somewhere within your net logon share. Someone's poking around your Active Directory environment, they will be looking for places like that. Shares that are available to all users. Things like group policy preferences, like you can name in like test change local admin account on all systems or something like that. Even if it's not currently deployed to an OU or to some machines, the fact that you say test, suggests that it was used at some point. So, they might try it. Or you can make it look like it's a shared account and we're using the the user description to store the password. We've seen that in environments. So, so things like that. So we talked a little bit about cyber deception, but we didn't even scratch the surface. A few years ago, MITRE came up with a MITRE Engage framework, which goes into greater detail on what you can achieve using cyber deception. So if today's talk piqued your interest in cyber deception, I will encourage you to check out MITRE Engage. So key takeaways, I think I only have like 30 seconds. You can leverage cyber deception to speed up the detection of intruders in your network. Combine it with centralized logging. Please don't allow your honeypots to advance the attacker's agenda, and check out MITRE Engage. Questions? Unfortunately, we don't have time for questions, but I'll be available in the corridor. Anybody has any questions, please grab me in the corridor. All right. Thank you so much.